All right, so this is going to be part one of integral problems with polar. If you missed the explanation video, definitely go check that out. A lot of good stuff there. So our first problem here, find the area of r equals cosine theta plus sine theta from 0 to pi. All right, this problem is just meant to get you comfortable with just integrating polar, all right? So we know our equation. Area equals the integral from a to b of 1/2 r squared d theta. Okay, now we're already given an interval. That interval is from 0 to pi, so we already have that part down. Now we have 1/2, of course, but we have our r squared, so that means that we're actually going to be squaring cosine theta plus sine theta. Of course, you probably see that we're going to get a cosine squared plus sine squared. That's pretty nice. But, all right, now we get the integral from 0 to pi of 1/2 times cosine squared theta plus cosine theta sine theta plus sine squared theta, and we get a d theta. All right, now simplifying this, we get the area of 1/2 the integral from 0 to pi of, this is now just a cosine theta sine theta plus 1 d theta. Now we can't do u substitution because we have that 1 there, so what we're going to do is just split up the integral, okay? That can actually be a stumper for a lot of people, okay? Just honestly, if you split up the integral, then it's actually doable, okay? That's actually one of the reasons why I ended up I messed up on a test doing that. So I can definitely relate if any of you get caught like that. But anyways, we get 1/2 the integral from 0 to pi of cosine theta sine theta plus 1/2 the integral from 0 to pi of d theta. All right, now we just integrate. When we want to integrate this piece right here, we need to set up a u substitution with u equaling sine of theta and du equaling cosine of theta d theta, which apparently I forgot that d theta part, no big deal. So theta equals 0 and u equals, well, u will then equal 0, sine of 0 is 0, and theta equals pi, u equals, well then we have sine of pi, which is also 0. So now we have bounds of 0 to 0, so we actually don't need to worry about this integral at all, okay? We just need to worry about this 1/2 integral from 0 to pi of d theta, okay? So this integral goes away because we can't have bounds from 0 to 0, and we're left with the area equaling, let's integrate this. Well, now we get theta evaluated from 0 to pi. Of course, we have to multiply this by 1/2 because that 1/2 is still there. So we're just going to get an answer of pi over 2. All right, so nothing really too challenging here, right? Just kind of an integral, but now you're thinking in terms of r and theta. So we have our next problem up on the board. We want to find the area enclosed by r equals 2 sine theta. Now this problem wasn't as generous as the last giving us our bounds, but we can figure that out, okay? Now we're going to figure that out is we're just going to have to draw the graph, all right? It's not super tedious as long as you first view r and theta as Cartesian coordinates, okay? If we view them as Cartesian coordinates, then it's like y equals 2 sine of x, right? It's not anything that we haven't done before. We know that graph looks like this. Okay, this point would now be 2 pi, this is 0, this is pi over 2, this is pi, and this is 3 pi over 2. Okay, so now you understand like where your max is, your next 0, your min, and your 0 to end that little wave, okay? So trying to actually graph this now, we have our polar axis, right? We have our pole right here, and we start off at 0. We're going to look something like this, from 0 to pi over 2, and then we go to pi the same way. So we get something that looks like this. All right, well, from pi to 3 pi over 2, well, now we're going with the negative r, okay? Because we're dropping below. Of course, this is r, This is theta. Sorry, I should have probably labeled that sooner, so hopefully none of you got confused by that. Going from pi to 3 pi over 2, r became negative. What that means is that we're actually just going to retrace what we did from 0 to pi over 2. Okay? If you're confused on anything that I'm doing right now, definitely go check out my graphing polar video. Okay? Anyways, back to this. All we have to do now is just find the area of this circle right here. Okay? We can do that by integrating from 0 to, honestly, this has symmetry, so we can just integrate from 0 to pi over 2 and multiply it by 2. Okay, so we end up with, we know that our area is equal to 1/2 the integral from a to b of r squared d theta. So now I can multiply by 2 on the outside. Like I said, I'm going to integrate from 0 to pi over 2 since this has symmetry. So I'm going to get the integral from 0 to pi over 2 of r squared. That's just going to be 4 sine squared theta. And we're going to get a d theta. All right, now we're just going to apply the half angle identity to the sine squared here and pull out the 4. Okay, when we do that, we pull out that 4 and we're going to get an over 2 from that half angle identity. So this is actually just going to become 2 on the outside. So we get 2, the integral from 0 to pi over 2 of 1 minus cosine of 2 theta d theta. Now we just got to integrate. So we get the area is equal to 2 times theta minus sine of 2 theta over 2. And we're going to evaluate this now from 0 to pi over 2. All right. We know that 0 is going to just kill off everything, so we got to worry about that pi over 2 term. That pi over 2, when we plug that in, we're going to get our area is equal to 2 times pi over 2 minus what? Well, we have our sine of 2 times pi over 2. That's going to be sine of pi. We know that's 0. So we're actually just going to get an answer of pi. All right. The area is just going to be pi. Now, I didn't draw it as such, but that's actually a circle, okay? And this is going from 0 to 2 on the top. That means it has a radius of 1. Okay, so if we just try to figure it out this way, area equals pi r squared, well, we know that our radius is 1, right? So that means that the area, we could figure that out in 2 seconds, that's pi. Okay, so we've now found something the calculus way that could take us about 2 seconds to solve, as long as, of course, we had the graph, just the way that we learned in 4th grade. Okay, so yeah, really efficient. All right, that's gonna do it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for integrals with polar, and the next video in the series. See you soon.